All right, AP, here's a sample exercise 3.42, molar mass and the numbers of molecules. Isopentyl acetate is a compound responsible for the scent of bananas. A molecular model of isopentyl acetate is shown in your book. I'm not going to include that. You can look it up if you want. But it's in the margins of your book. Interestingly, bees release about 1 microgram, which is 1 times 10 to the negative 6 grams, of this compound when they sting. The resulting scent attracts other bees to join the attack. How many molecules of isopentyl acetate are released in a typical bee sting? How many atoms of carbon are present? Go ahead and press pause now because here comes the solution. So since we're given a mass of isopentyl acetate, we want to find the number of molecules. We must first compute the molar mass. So given that isopentyl acetate is C7H14O2, again that was given to us by the question, we calculate the molar mass of isopentyl acetate to be 130.18 grams. This means that 1 mole of isopentyl acetate, again that means 6.022 times 10 to the 23rd molecules, that's Avogadro's number. 1 mole of isopentyl acetate has a mass of 30.18 grams. To find the number of molecules released in a single sting, we must first determine the number of moles of isopentyl acetate in 1 times 10 to the negative 6 grams. Again, where are we getting that number from? From the question. So we take our 1 times 10 to the negative 6 grams of isopentyl acetate and use the molar mass that we just calculated to convert away from grams of isopentyl acetate into moles of isopentyl acetate to give us a value of 8 times 10 to the negative 9th moles of isopentyl acetate. Since 1 mole is 6.022 times 10 to the 23rd units, we can determine the number of molecules in this way. We take this value for the moles of isopentyl acetate, use Avogadro's number to set up a conversion factor to convert away from moles and into molecules, and we generate a value of 5 times 10 to the 15th molecules. To determine the number of carbon atoms present, we must multiply the number of molecules by 7. Why? Because the formula for isopentyl acetate has 7 carbon atoms. So we take the number of molecules that we just generated, okay, 5 times 10 to the 15th molecules, use the conversion factor of 7 carbon atoms per 1 molecule to convert away from molecules and into a unit of carbon atoms. Simple arithmetic gives me 4 times 10 to the 16th carbon atoms. Note, in keeping with the practice of always showing the correct number of significant figures, here this problem is rounded after each step, okay, after each single step, so that each time you can practice understanding how many significant figures should be there. However, when you're doing long calculations, you don't have to do that for each intermediate step. You can simply do it at the very end just once. Okay, that's perfectly acceptable. It'll save you time on the AP exam, and AP scorers understand that that you're doing that and will not give you questions that will significantly change the value of your final response if you're rounding after each individual step or at the very end. Also, if you practice a particular problem and the answer given for that problem is a few decimals, like a couple of hundredths off, a very, very, very small difference, that's usually the difference between the book rounding after each intermediate step and you only rounding at the end. And that's totally fine. That is 100% A-okay. No bad stuff will happen to you doing that.